Hello friends, this is Eli from Mystic Circuits. Today, I'm showing off a patch where we take one modulation source and we turn it into a whole bunch of modulation sources. This is not really a patch where I'm going into some secret behavior that Anna unlocks if you get into the nitty-gritty of how it works, as much as a sort of strategy that I use for patching with Anna when I have modules in particular that have internal modulation sources that let me sort of self-patch into bits of the module where Anna might be able to sort of intercept that internal modulation and make it a little bit more interesting. So in this case, I have the Grackle, which is a module that I've been beta testing for a new company. Some of you might know that I've worked in the past with Omi Industries. Naomi from Omi was very kind in letting me be an early adopter of this module. I've been having a lot of fun with it, and so that's part of the reason why I wanted to do this patch, is to show you a cool way that I've been using Anna with this particular module. Just to go over the module really quickly, it's a phase modulation oscillator, right? Similar to frequency modulation, but more stable in pitch. And it's a digital module. Basically, you have your carrier oscillator. Currently, this slider is set up to switch octaves, which is really nice because I can change the pitch without having to retune everything. And then there are these two modulation oscillators that are frequency multiples of our carrier oscillator. So if I turn up the depth, you can start to hear that classic sort of Yamaha DX7 kind of sound. And now each modulation oscillator is set up to be an integer multiple of the carrier oscillator, which is nice because that means that everything is always in tune. You set the numerator with this slider, and then you can set an overall denominator with this switch. You are also able to set a denominator by supplying this oscillator with a negative voltage to its interval input. But we'll address that later. Anyways, you have two of these oscillators, right? So here's the second one. I believe that because the algorithm is set up in a particular way, that one was modulating the second modulation oscillator. So if I do this, we should hear the effects of the first modulation oscillator. There are these three different algorithms that you're able to use for it. But one of my favorite things about this module is that it has these really handy outputs for self-patching modulation. You'll see here you have the envelope out and you have the mod out, which I'm pretty sure, I gotta double check the manual on this, but I'm pretty sure that this is just a direct mix of both of your modulation oscillators, which lets you do some interesting self-patching or patching to other things. You can see here I have a filter already set up. You might not know this is a filter. This is actually one of my favorite filters. I'll go into this module in another video, but the Sprott is a fantastic sounding filter. And basically, this is sort of superfluous because the envelope out is actually normalized into your depth inputs. But let's say I wanted to take my envelope. It has this internal envelope generator with they call it growth. It behaves a little differently than attack, but the decay behaves exactly how you would expect it to, right? And so now I'm going to take this envelope and just patch it into one of the interval inputs, right? Here's our attenuator. So you can already see like there's some interesting possibilities for self-patching here, right? So but we're limited by the fact that we have only one envelope out and I'm patching it into one modulation input, right? So what I'm going to do instead, I'm going to put all the modulation down, I'm going to patch it into Anna. Bet you didn't see that coming. So now what I'm going to do, I'm going to take our cut output, patch it into the depth. I'll take maybe the min output. I like min for modulation amounts because it only turns on sometimes, so it gives us a little bit more variety, right? Our envelope is going into the main input 1. If I turn this up, oh, I have to turn up the attenuators up here. Maybe turn these intervals up a bit. You can hear that our envelope is impacting the way that different pieces are modulated. I'm going to change the mode. With our second channel unpatched, this knob becomes a sort of static control, so I can actually zero out our envelope and use this to control the modulation amount on both inputs simultaneously. It's obviously more interesting when we use our envelope, right? So you can hear, even with our attenuator, our attenuverter reversing the polarity of our input envelope and then using this as a sort of static offset, we're able to get a sort of rising depth so that the frequency modulation depth increases as the note is on for longer, which is inverse to the amplitude envelope that's happening. I think we'll possibly get some more interesting stuff by patching some of these other outputs into, let's say, the interval. I like swap because it'll normally stay at a specific value. Every once in a while, it'll jump to something else. See, these right angle cables drive me a little crazy because they're really useful for videos, right? But it also, I'm not going to be able to patch into this XOR input, right? Because it's covered with this forest of cables. But anyways, taking the step out, running it into the modulation 2 input, swap, going into, I apologize, interval. Both interval inputs are being modulated by the step and swap outputs. If we mess with some of these knobs, you can already hear we're having a huge effect on our grackle. Right? So, and you can see having the offset up and inverting the envelope gives us the sort of swelling sound. It's a nice, like, pseudo horn kind of sound, right? But you can hear that as the envelope decays, the depth increases, right? So that gives us a nice way to have an envelope have multiple kinds of behavior. As I was talking about before, the growth parameter is pretty interesting on this, but basically it gives you a way to sort of do both attack and velocity at the same time, because the envelope only increases while a gate is present. So if your gate is shorter or longer, that changes like the highest point, the highest amplitude that the envelope is going to achieve. I have an iDum off screen changing the gate length of our gates coming into the Grackle. So something else I'm going to do is take one of our outputs and use it to modulate the growth. Which has a much larger effect than I was expecting. I think you can hear we're having some of our modulation oscillators go into sort of negative LFO territory. This is probably a good time to patch in our filter. So I have this magnitude output. I'm going to use it to modulate the frequency of our filter. Currently, I have both the high pass and the low pass being mixed together, but let's do a low pass. I'm going to go ahead and modulate the decay as well. So now we're not only modulating all of the modulation oscillator parameters, we're also modulating the behavior of the envelope that's going into Anna itself. So might turn these down a little bit just so I can predict, because the envelope is also modulating the amplitude of the oscillator. It's good to sort of reduce the amount of complexity that we're getting into the envelope itself. No, it might help with that. Let's take box. I'm currently crossfading between the low pass and the high pass using 3D VCA, but if I put this in the middle, we should get both a mixture, the low pass and the high pass, sort of switched between. You can hear we're just using Anna in order to get all of this behavior, right? We're able to get into sort of like normal, somewhat pretty territory, and then just really quickly go into crazy download your brain to the matrix kind of sounds, right? And again, with this knob being just a static voltage, we get to control the overall offset of all of these modulation sources at once. So with that in mind, what I'm going to do is I'm going to patch in an analog voltage sequencer, being tree, also off screen. And what that's doing is it's changing the offset voltage that we had patched into this knob before on every step, right? We're able to change the amount that it offsets, the modulation voltages, control the overall amount that the sequence changes our oscillator behavior. And this is a really nice way to sort of let us have different types of behavior on each step of our sequence. We could, of course, change this to be an offset. Get a little bit more control over whether our sequence is going positive or negative voltage-wise. You can hear we're getting a lot of variety out of the actual sounds happening on the grackle. Just to demonstrate, I'm going to turn down all of the modulation. Right? That's what it sounds like with no influence from Anna, even a little bit, right? Happening over here, right? Now, Anna's just influencing the envelope behavior and the filter, and of course the crossfader. And now it's just influencing the modulation depth. And now it's doing all kinds of stuff. Oh yeah. I really like it sort of alternating between sending our modulation oscillators into like LFO sort of fart sound territory, and then jumping into our really more complex metallic sounds, depending on where the second input analog sequencer is leading things. You can see when the light turns red, right? We're getting our wobbliest of sounds, whereas when things go green, which I realize with this lighting does not show up the same way that the red does. Working on the lighting, I think it gets a little bit better with every video, but you could sort of tell when things get real red, that's when we're getting the sort of throatier, wobbly sounds. I haven't actually done this before filming, but you know what? Just for fun, we're going to try plugging this into our modulation oscillator output. If I can do it without destroying the jacks. Here we go. So now, all of the modulation sources internal to this module are modulating themselves. I'm told that a lot of these modulation inputs, while they're not full audio range, they are a fairly high sampling rate for your typical modulation input. So you're hearing a little bit of that downsampling there, which is going to be made more intense because of the feedback, but trying to sort of tame it by making the envelope shorter. You can hear as I make the envelope longer, it's more likely to sort of hit the limits of its own self-modulation, right? Wow. I realize these sounds aren't everyone's cup of tea, but I love this kind of stuff. You know what we could do? Alright, here's what I'm gonna do. What I'm doing instead is I'm plugging this into here, right? That lets us control the overall. Plugging the modulation oscillator into the main input lets us control the overall amount of feedback, right? So at noon, there's little to no feedback. Negative, it's inverted feedback. Positive, it's increased feedback. Now, I'm going to take that voltage sequence from leaves. I'm going to plug it into the multiply input. So now, leaves is controlling the amount of feedback that there is in this patch. I don't know, that sounds pretty good to me. So anyways, it's very noisy sort of example. It's a good way to get a lot of control over how you self-patch a module. Basically, having Anna in the mix for this sort of setup. I mean, just look at this. We're not even touching our original module. We're just messing with Anna. So, I think you could tell Anna will do a lot for self-feedback sort of modulation patches. Even if these sounds in particular aren't your jam, I think you can see the power of this sort of setup. So, anyways, I appreciate you taking some time to stop by, watch this video. I hope you're all having a wonderful day. Thank you for watching.